Hello fellas, it is assignment A12, adding, subtracting radicals. So we're almost there. This assignment is going to be for you to work on today and tomorrow, Monday and Tuesday, and I'm going to have one more assignment for you to work on Thursday, Monday, and this one's for Monday and Tuesday. I'm going to have one more for you to work on Wednesday, and then one short quiz on simplifying nth roots and square roots and adding and subtracting radicals and multiplying radicals, which we will do Wednesday. Okay, so once again, this is Monday and Tuesday, today and tomorrow. I'm going to give you one short assignment Wednesday and one short quiz Thursday, and that's it. You're done. So keep up the good work. You're almost there, almost there, almost there. This is the hardest part of any challenge right at the end. You cannot put the ball down and leave it there in the fourth quarter. You're almost there. You're doing great work. You guys are by far the best at all the Algebra 2 stuff that we've done that I've ever taught. Right? You guys are doing awesome. You guys are superstars. Keep it up. Don't falter in the fourth quarter. Okay, so adding and subtracting radical expressions. Remember that anytime you have a product of something, you can think about coefficients. And if you think about the coefficients correctly, you can make the problem easier for you. Remember, I've always showed you things like if you have something like 3 times 17 plus, I don't know, maybe 27 times 17, you know? Don't go to your calculator right away. This is 3 17s and this is 27 of them. Together there are 30 17s, right? So do what you can. Use your prime factorization of numbers to use coefficients to your advantage. Okay? How many square roots of 7 do we have here? I know I can't hear you, but say it out loud anyways. Exactly, 21. And we're going to subtract how many of them? Somebody say it. I'm not going to do anything. I'm not going to say it until somebody says it. 35. Good. 21 minus 35. If I have 21 of something and I take 35 of them away, I am at minus 14 square roots of 7. Not bad, huh? So, 7 square roots of 15. You ask yourself, can you simplify the square root of 15? Are there any perfect squares that factor it? There are not. So we're going to leave that there and we're going to work on this one. What is the biggest perfect square that you can think of that divides 60? I think the biggest one that I can think of is 4. That is, 60 is the same as 4 times 15, or the square root of 4 times the square root of 15. Now maybe I want to skip a step on this first example. I'm going to rewrite 60 as 4 times 15, and then I'm going to say if I have a square root of a product, I can write it as a product of square roots. And so I can write 7 square roots of 15 minus 3 times the square root of 4 times the square root of 15. What's the square root of 4? 2. So we have 7 square roots of 15 minus 3 times 2 square roots of 15, or 7 square roots of 15. Take away 6 of them. How many are you left over with? Yeah, that's right, just one of them. Square root of 15. Okay? This is very, very, very powerful technique because you can do lots of things with square roots to make them look different. Remember how we multiplied by smart ones to change the way fractions appear? We even have more tools at our disposal with square roots, and we can make them do what we want. That's why math is superior to all the other disciplines. Except for blowing stuff up. That's a good discipline too. Okay, let's simplify this the best we can. Square root of 27, can you simplify that? Well, the biggest perfect square that divides it is the square root of 9, so I can write the square root of 27 as the square root of 9 times the square root of 3. And likewise here, a 4 divides it. Right? Square root of 12 is the same as square root of 4 times 3. So we have 3 times 3, square root of 9 is 3. 3 times 3, square roots of 3, minus 5 times 2, square roots of 3. Or 9 square roots of 3 minus 10 square roots of 3, and we're left with minus 1 square roots of 3. Okay, last one. Square root of 32, what's the biggest perfect square that divides 32? That's right, 16. So we rewrite the square root of 32 as the square root of 16 times the square root of 2, and we can write the square root of 50 as the square root of 25 times the square root of 2. Let's see. 3 square root of 16, 4. 3 times 4 square root of 2 minus 2 times 5 square root of 2. 12 square roots of 2 minus 10 square roots of 2 is 2 square roots of 2. Okay, that's simple. It's not hard. It's a little tricky, and we just need you to practice a few, right? Give it a go. I'm going to give you a worksheet. Do enough of them to make sure that you're good at it, right? I'm not going to say do the odds, do the evens. You guys are rock stars, so pay attention to yourself. Remember that you are not doing this for me. You are not doing this to get through this class. You are doing this to be the most mathematical boss that you can be. Okay? So don't shoot yourself short, and I love you and miss you. Oh, my hair's getting long too. I love you guys so much that I have not showed my hair on any video except for this one. I miss you guys truly. You guys are a wonderful group. I have really, really, really got to appreciate you, and you know, you are certainly amongst one of my favorite classes that I've ever taught, especially for Algebra 2.